Hi, today is going to be your first video. It's going to be for day 2, understanding points, lines, and planes, more of what we did in class today. So the first thing it's important to know is the 3 undefined terms of geometry. So these are the 3 most basic terms that we're going to use to define other things that we learn about, and that is the point, the line, and the plane. You will have to know that, and you will have assessment questions on being able to name those 3 things. So we get into the first question, how many points does it take to make up a line? So it's going to require us to have 2 points. Any 2 points we draw, no matter where we put them, those 2 points are going to make a line. The thing is, the line is going to extend forever and ever and ever. It's never going to stop. Because it extends forever, there are an infinite number of points on the line. So we only need 2 to make the line, but once we have the line, we have an infinite number of points on that line. How many points does it take to make a plane? That is 3 points. And that's going to be 3 non-collinear points. Again, just because it takes 3 points to make the plane, once you have your plane, there's an infinite number of points on that plane. So more about these 3 words. 2 lines are going to intersect at, here's one line. Doesn't matter where you draw that second line, when they intersect, those 2 lines are going to intersect at a point. If you have a line and a plane, so we've got our plane, we've got our line intersecting that plane, it's going to go through, so we're going to do a dashed line because we can't see that part of the line. Then it's going to come back out the bottom. When I have that plane, like a piece of paper, and I have a line going through that paper, it's going to intersect at a point as well. And last, when we have 2 planes, so if I have one piece of paper and I line up another piece of paper next to it, so those 2 papers are meeting, those 2 papers are going to meet at a line. Remember, when we draw our plane, it looks like it has a starting and ending point, but it's going to continue going in all directions. It's never going to stop, just like a line never stops. Identify and name the geometric figure. A lot of notation in this first unit. So when we look at this first picture, I notice that it's going to be a plane. When I go to name that plane, I can either name it with 3 points on the plane, which I don't have any points, or I can name it by the capital cursive letter. So this would be plane D. When I look at part B, I see that this is going to be a ray. I know it's a ray because it has a starting point and it extends forever towards another direction. So it has one endpoint and one side that never ever ends. When you are writing the notation, you always start at the end point where there's a definitive spot. It's going to go forever and ever towards N. So I'm going to draw my arrow towards N. When you write it, it's always going to have an arrow going to the right, regardless of which way the arrow is going in your diagram. One little dot there shows me that I'm going to have a point, and a point is written with just a capital letter. You don't even have to write point if you don't want to. In part D, we have a beginning and we have an end. It's not extending in either direction, which tells me that this is going to be a segment. And when you write the notation for a segment, you write your 2 letters and 1 straight line above. Now, it doesn't matter if you start at N and end at P, or you start at P and end at N. Because you have a starting and end, I'm not extending in any direction. In part B, I have to put the M first because that's my starting point. In E, it looks very similar to D, but because I have added those arrows on the end, it's never stopping in either direction. So I could say that this is going to be line AB, and I have the correct notation above, or I can switch it and put BA. It doesn't matter the order of your letters. And then I see this M over here. I could also name this line M. That's a lowercase cursive letter. All right, we want to draw and label the situation. So we have line M intersecting plane B at A. Very similar to what we did above. So we have our plane. This plane is plane B. I'm going to have a line cut through that plane. When it cuts through, it's no longer visible, so I draw that dashed line and it comes out the bottom. This is our line M, and the point at which it goes through that plane is point A. Just being able to interpret those letters there, those words, and knowing what it's going to visualize as. We look to the right, use the figure to answer the questions. Identify all collinear points with both A and D. So collinear means that it's on the same line. So when I see D and I see A, I want to name every other point that's on the same line as A and D. So along this line, I look here, I see point C is there and point F. So those are the only 2 points that are going to be collinear with D and A. Collinear again meaning that it's on the same line. Name FA in 2 additional ways. So when we see this symbol up here, that tells me it's going to be a ray, and rays can be a little tricky. So as we look here, we see, I want to change pen there. So I see F. This tells me that it's going to start at F, and it's going to extend towards A. As I extend towards A there, the important thing that is it started with F. It's not existing anywhere before F. So when I name that, I have to start with F no matter what. Now I can go to F to D because it's extending forever towards D in that direction. So it's going to forever, it's not going to stop at D, it's going to forever go and eventually get to A. I could also say that's ray FC. The important thing is I have that starting point of an F, and that arrow means that it's going to continue towards C forever and ever and ever and ever. Since D, C, and A are all in that direction on that line, it doesn't matter if I say ray FD, ray FC, or ray FA, it's going to forever extend in that direction. So they all are representing the exact same ray. Name 3 points that are coplanar. So coplanar means that they are going to lie on the same plane. Now above we said that it takes any 3 points to make a plane, any 3 non-collinear points. So I can pick any 3 points I want just as long as they are not on the same line. So I can't pick A, C, and D because A, C, and D are in the straight line, but I could pick A, B, C. I could pick F, E, D, D, E, C, C, E, A. So there's limitless options here on what I can pick. That's not true, not limitless. There's a certain number that I can pick. They just can't be on the actual same line. And last question, one of the most important questions is, does the line DE exist? So here's D, here's E. Your instincts are going to tell you no, D is a point and E is a point. But the answer is actually yes, it does exist, because any 2 points form a line. If I look here, here's point D, here's point A, I can draw in a line. So it doesn't have to be drawn in to exist. And if you remember above, we said how many points does it take to make a line, and we said 2. So no matter what, if you have 2 points, you can make a line. Just because it's not drawn doesn't mean it's not going to exist. All right, that is it. We are all set and done with our first video on understanding points, lines, and planes, 3 undefined terms of geometry.